Welcome to the deep dive. Our mission here is pretty simple. We take the complex knowledge you need to master, we distill it down, and we give you that competitive edge. Today, we're focusing on something that is absolutely essential, the physical foundation of our modern lives. We're taking a deep dive into the tangible, the enduring legacy of professional engineering and geoscience, and that is infrastructure development. And this isn't just about, pouring concrete. It's the very bedrock that enables economic prosperity, social stability, and really all public well-being. It is probably the most visible and consequential contribution these professions make to society. So our goal today is to unpack the core professional duties, the fundamental roles, and the strict ethical obligations involved in creating communities that aren't just surviving, but are safe, efficient, sustainable, and truly resilient. We want to give you those precise, high-impact insights that really stick with you. Okay, let's get into it. But briefly, before we jump into the details of professional practice, if you are looking to master this core content for your future career success, and especially if you're studying for your professional entrance examination, make sure you subscribe right now. You'll hear much more on the crucial topics needed for the NPPE exam.
So, to properly frame this discussion, I think we have to start with a clear definition. When we say infrastructure, what are we really talking about?
Good question.
It refers to the integrated systems and structures that enable a society's core economic and social functions.
Mm-hmm.
It's the connective tissue, really. It's a blend of technical design, geoscientific investigation, and pure technological innovation.
And the scope is it's staggering. It's so much more than what you see on your morning commute. The material breaks this down into these huge interconnected categories. You've got transportation, so that's railways, seaports, airports, and of course our massive highway systems. Then you have utilities, which covers electricity grids, natural gas lines, renewable energy facilities.
Exactly. And don't forget communications.
Right.
I mean, that now includes the absolutely critical fiber optic cables and internet networks that our entire modern economy runs on.
Right.
Plus, you have the public systems like water treatment and waste management, which are essential. And even our public institutions, our hospitals, our schools, they're all fundamental pieces of infrastructure.
What's really crucial for you to understand is that building these mammoth systems, it isn't a chaotic endeavor. It's a systematic framework. There are 5 core stages in the infrastructure development process that, guarantee alignment and longevity.
Right, a roadmap.
Exactly. We start with needs identification. So that means assessing what the community actually requires now and, looking into the future. Then you move right into feasibility and planning. This is where the paper meets reality.
And that second stage, feasibility, it's deceptively difficult. It's where professionals evaluate the technical viability. I mean, can we even build this thing? Then there's the long-term environmental consequences and, critically, the financial reality of the project.
So if you rush that part.
If you rush feasibility, you pay for it exponentially later. It's a huge mistake.
Once that planning is sound, you get to design and analysis, applying those really rigorous professional principles to create safe, efficient solutions. And that's followed by construction and implementation, executing the design exactly within all the regulatory boundaries.
And finally, you get to the stage that determines the structure's entire lifespan. Operation, maintenance, and renewal. You have to constantly guarantee reliability and adapt the infrastructure over, decades.
So it never really ends.
It never ends. And if we connect this to the bigger picture, the success of those 5 stages relies completely on intense collaboration, not just between engineers and geoscientists, but with policymakers, financiers, and the public they serve.
That partnership brings us perfectly to our next point, which highlights 2 distinct but, absolutely inseparable roles. We often talk about engineers as the heroes, right? The people who build the bridges and the power plants. But before that first blueprint is even signed off, someone has to understand the ground itself. So how crucial is that initial professional partnership?
It is the difference between success and catastrophic failure. There's no other way to put it. Think of the engineers as the creators and innovators. They're the ones who translate abstract requirements into tangible functioning systems.
Right, they make it real.
They make it real. They design a bridge not just to stand up, but to withstand heavy vehicle loads, wind shear, and especially here in Canada, most extreme temperature swings and ice loads you can imagine.
They're the ones developing the sophisticated renewable energy grids and creating the efficient transportation networks that literally define our economy. But they're designing for a very specific physical environment.
And that's where the geoscientists become the foundation experts. They are the necessary reality check for the entire project. Their whole job is to ensure that what the engineers design rests on a sound, stable physical base.
So they're looking at the soil, the rock.
Exactly. Assessing soil, rock, and groundwater conditions for stability.
Yeah.
But their most critical role, it's identifying geological hazards.
It's like earthquakes.
Earthquakes, yes. We're talking about finding potential faults, understanding the risk of liquefaction during a quake, or predicting flood pathways and landslide susceptibility before construction starts. What's fascinating here is the absolute necessity of this partnership.
So without that geological insight,
If a project proceeds without it, or if that insight is ignored, the resulting infrastructure could face catastrophic, life-threatening failure. They must collaborate seamlessly from the drawing board to the final sign-off.
the stakes are just incredibly high. Okay, so once that foundation is solid, the work these professionals do, it reverberates. And that brings us to the triple impact: economic, social, and environmental. Let's start with the economic significance. Infrastructure is much more than a cost. It's a strategic investment.
It absolutely is. Well-developed infrastructure is fundamentally about enabling commerce. It dramatically reduces logistics and production costs for literally every industry that uses it.
So it makes everything more efficient.
Immediately more efficient. Infrastructure investment often provides a strong return. It boosts GDP, and it attracts both foreign and domestic investment by transforming what was a regional risk into an economic opportunity.
We can see that historical truth perfectly right here in Canada. I mean, think about two massive projects: the Trans-Canada Highway and the St. Lawrence Seaway.
Nation-building projects.
They really were. They weren't just construction, they were nation-building efforts that revolutionized trade. By connecting Western markets to Eastern ports and allowing ocean-going vessels deep into the heart of the continent, they just fundamentally shaped our national economy.
And allowed for massive resource extraction and development. Plus, this kind of activity fuels incredible job creation. Major infrastructure projects require employment across every single sector: design, construction, operations, maintenance, all of it.
Which stimulates local economies.
A huge demand for materials and technology. Exactly.
Beyond the dollars and cents, though, there's a profound social value. Infrastructure is directly linked to quality of life. Access to clean water, reliable energy, safe roads, that translates immediately into better public health, improves safety and stability for every citizen.
And this leads us to the critical consideration of accessibility and equity. Professionals aren't just building for the wealthy cores of large cities. They have an obligation to plan systems that consider everyone, especially remote, indigenous, and low-income communities, to actively reduce inequality.
It's about building inclusively.
Yes, guaranteeing fair access to essential services. And, of course, these structures often become defining symbols. Like the Confederation Bridge or the Hydro-Quebec power systems. They really embody our national identity and progress.
And here's where it gets really interesting for me: the environmental and sustainability considerations. For any modern project, balancing human needs with environmental stewardship is completely non-negotiable.
It has to be.
That means we have to move past simply checking boxes. Professionals are now required to focus on reducing carbon emissions, minimizing ecological disruption, and importantly, incorporating life cycle assessment, or LCA, into the design.
Can you unpack LCA a little?
Yeah, it means they are planning for the environmental costs, the use, and the eventual decommissioning of the structure over its entire lifespan, not just the initial build costs.
Okay, so from cradle to grave.
Exactly. And given the dramatic changes in our global climate, the concept of climate resilience is now paramount. Designing for extremes like increasing floods, severe wildfires, or rising sea levels, it can sound prohibitively expensive.
And that's the tension, right? This forces professionals to balance that massive resilience investment against immediate budget pressures. It demands that they adopt forward-thinking risk management to protect the public and, drastically reduce the exponential economic costs of future disaster recovery.
That's a tough balancing act.
It is, and it brings us to the very bedrock of their vocation: ethical and professional responsibilities. The foremost ethical obligation in any infrastructure development is protecting the public, period, full stop.
The history books are just full of examples of how high the stakes are. Failures, a bridge collapse, a dam breach. They don't just cost money, they destroy lives, and they irrevocably erode public trust in the entire profession.
Yes, and that trust is everything.
Professionals are held absolutely accountable for rigorous testing, compliance with safety codes, and ensuring that independent review is just part of the process.
And that ethical practice extends into what we call stewardship for future generations. This demands advocating for sustainable solutions, even when you face financial or political pressure to cut corners.
Which must happen all the time.
All the time. Professionals must communicate risks and limitations transparently. They are ethically bound to design for the next 50 or 100 years, not just for the next fiscal quarter.
Looking ahead then, the future of infrastructure in Canada is being shaped by some tremendous technological innovation. We are moving toward what's being called smart infrastructure.
Right, so what does that mean in practice?
It means integrating digital tools like AI, building information modeling, or BIM, which is essentially creating a comprehensive digital twin of the project and the Internet of Things, or IoT. That allows for millions of sensors to provide real-time monitoring and adaptive, predictive maintenance.
So the bridge can tell you when it needs repairs.
In a way, yes, before a human might even notice. And we're also seeing new design directions, notably green infrastructure things like using urban forests, permeable pavements, and natural stormwater management systems that integrate ecological principles right into urban planning.
And critically, future development must respect Indigenous rights and incorporate traditional knowledge. That's essential for truly equitable development across Canada's diverse landscapes.
Yeah.
So if I had to distill all of that down, it sounds like infrastructure professionals are fundamentally risk managers and stewards of civilization's foundation, who are just disguised as builders. Their work expands markets, enhances health and safety, encourages sustainable resource use, and it reflects our national innovation and unity.
That's a perfect synthesis. For you, the listener, the essential takeaways are these. Infrastructure is the most visible and enduring contribution your profession makes. Its success hinges on a collaborative partnership between engineers and geoscientists. An ethical practice is the safeguard that protects both the public and future generations.
And here's a final provocative thought for you to consider. Sustainable infrastructure management requires proactive inspection and continuous rehabilitation, not reactive, emergency repairs. So, what critical piece of infrastructure in your community needs immediate renewal right now to prevent a costly failure and ensure resilience for the next generation?
That's a great question.
Think about that every time you cross a bridge or turn on a tap.
Fantastic. Something significant to mull on during your next study session. Thank you for going on this deep dive with us today. To continue building this essential knowledge and to hear more about how to be successful on your NPE exam, be sure to subscribe to hear more deep dives just like this one.